Alrighty guys, I'm going to make my second attempt at a video for you and see if I can really get this up on. I'm gonna really try some things today. Alright, so you have, if you watched the Zoom video from yesterday, or if you went live actually with me and you were there in person, then you know that we started talking about graphs of polar equations, but ones that could have been converted. So, like for example, as a recall from that video had something like r equals -3 sine theta, and you could have converted this into the rectangular version, which converting it would have led you to x squared plus y squared equals -3y, which would have brought you down to, actually, I'm so sorry, this was not 3, this was, I believe, a 6. And so this would have converted us down to x squared plus, it was actually on the quiz as well, y plus 3 quantity squared equals 9, which means that you had a center centered at the point 0, -3, with a radius of 3. And we walked through how to make this into a, like a r comma theta chart, and we could have plotted points up along here, like plug in 0, plug in pi over 4, plug in pi over 2, plug in pi or 3 pi over 4, etc. So you could have plugged in some points, etc. And we showed how this would plot. So the reason why it's important to kind of understand that is because there are graphs that you cannot convert into the polar form. And we are going to look at the first one, which is about rose curves. So I usually like to start with the rose curves because they're so pretty and beautiful. So we'll start with some rose curves. All right, and they are called rose curves because when you graph them, they look like flowers. So let's take an example like r equals 3 cosine. Actually, you know what? Let's do 4. 4 times the cosine of 3 theta. We're going to plot it onto a polar graph. And since this is one that you've not done before, we're going to do it. I'm going to use this guy right here. Let me just put him in the background, and then I'm going to actually change, I should have probably gotten this ready ahead of time, but you know, live and learn. I'm going to make it where these are actually going to be, every circle, every ring will be half a unit. So I'm going to get rid of these and change it if I can. Just because I think it'll make the picture be a little bit clearer. Oh, and then I'm also going to add on here 15-degree increments. So I'm going to put in a 15-degree section here because I want to count by 15 degrees. Put in a 15-degree section here, so that would be what, 75? I'll need to go the opposite direction as well sometimes, so remember, if that radius is negative, you got to go the opposite direction. And then I'm going to have this be every 2 rings will be 1. So that'll be 1, 2, 3, 4, and just make the picture a little bit larger for you. Okay, let's do set up our table like we did in that Zoom conference we did yesterday. Those of you that haven't watched it, you really should watch it. I'm going to do every 15 degrees up to 90 just to start us out. So 0, and there's no reason why I'm doing degrees versus radians. I think I'm just matching my picture over here. So that's why I'm doing it this way. 0, 30, 45, 60, 75, and 90 degrees. We'll have to go farther to see the whole picture, but we'll just start there. And then I'm going to be plugging them into my r equals 4 times the cosine of 3 times, and then whatever the theta is, it's going to go right there. So I'm going to start with the 0 degrees. And I know you can use your calculator. I know you can like find this out with this, but I'm going to do it without the calculator, for this first part, because you should know that the cosine of 0 degrees is 1, and that 1 times 4 is 4. So when I go to a angle of 0 degrees, that puts me on the positive x-axis here, and the radius is positive, so I go out on that side to a circle of radius 4. So this is where that point should be plotted. So I'm going to plot it right there. Okay, go to 15 degrees next. So I'm going to get rid of, just trying to conserve space here, I'm going to get rid of this 0 degrees here, and I'm going to plug in 15 degrees. So 3 times 15 puts me at a cosine of 45 degrees. Cosine of 45 degrees is square root of 2 over 2. Now this I am going to use my calculator for. So I am going to figure out that the square root of 2 over 2 times 4 is about 2.82, just so that way I can plot it on my graph. So again, you're going to go to your angle 15 degrees here. Radius is positive, so you're going to go 2 and then a little more than halfway, so about right, maybe there. So maybe about right here, just approximating. So I've gone from this point to this point, kind of curving as I'm doing it. All right, 30 degrees is next. So now I'm going to plug in 30 degrees right here, which means I'm going to have the cosine of 90 degrees technically, and I hope you realize that the cosine of 90 without a calculator is 0, and 0 times 4 is 0. So when I am at a angle of 30 degrees right here, I am at a radius of 0, so I'm actually at the origin. Actually, the origin is called the pole when we're in polar coordinates. So I've gone from that point to this point to this point. I'm trying to make it curvy because it's not just going to connect in straight lines. It's just I'm not plotting all the points. Alrighty, 45 degrees. So 3 times, and again, I'm just going to, I'm not going to keep rewriting it here, but just know that I am going to keep putting it in, that measurement in to the theta. So when I get to the next point where I plug in the next angle, it's going right there for theta. So 3 times 45 degrees puts me at 135 degrees. Cosine of 135 degrees is now a negative square root of 2 over 2. Remember, we had come out with square root of 2 over 2 times 4 to be 2.82. That just means now this is a negative 2.82. So when you go to a 45 degree angle right here, if the radius is negative, you have to go the opposite direction. Remember, every ring is only a half, so that's 1. That's 2, that's 2.5, so maybe about right there. Let me plot that. So 1, 2, maybe about right there, I think is what I said. Okay. All right, then I'm at a 60 degree angle. 3 times 60 degrees, remember it's getting plotted right here. So 3 times 60 puts me at 180 degrees. Cosine of 180 is negative 1. And negative 1 times 4 is negative 4. So when I go to my circle, or excuse me, when I go to my angle of 60 degrees, I'm going out the opposite direction to a radius of 4. Remember, every one is a half, so that's 1, 2, 3, 4. So right out here. Right here. Okay, so this would have come and grabbed this point and then grabbed this point. We're not trying to make them pointy, you're trying to make them curvy as they plot to it. Okay, 75. So again, 75 is getting plotted right here for the theta. So 3 times 75 is 225. Cosine of 225 is again negative square root of 2 over 2. Negative square root of 2 over 2 times 4 will give me that approximate negative 2.82. Which means that on the 60 degree angle, wait, where am I? 75 degrees, excuse me. 75 degree angle, you gotta go the opposite direction. So I'm gonna be right about here again. So right about there. And then when I go to 90 degrees, I get 3 times 90, which is 270. The cosine at 270 is 0, so 0 times 4 is 0. Which means that I am back at the origin. So you couldn't really see me plot it there because it was right at it, but I'm right back at the origin right here. So I'm going to come back and connect back to the origin. Ooh, trying to make it curvy. Okay. So if I want to be able to continue this on, I'd have to do exactly what I have here. Try to make it smooth. So I've got to do exactly what I have here, but I've got to go from, 90 now to 180. I got to add on more points here. So far I've got my plots that went like this and came around, and then I've stopped here. So I do not have a whole picture. This is not the entire picture. So I do need to keep going if I want to see the rest of it. So I'm going to suggest that you pause it here and that you do that yourself. I might, who knows, I might put this up into Edpuzzle and maybe I'll have you guys pause it and I'll automatically have the video pause. You know what? I think I'm going to do that. I think I'm going to automatically have the video pause. That's a great idea, Ms. Griffith. Okay. While I draw this here, so you're going to basically make another R theta table. And you're going to go, I need more angles here. So I need that one, and I need this one, and then I'd have to go the opposite directions as well for when I've got negative values. So that'll be what, 90, 105, 70, 165. So we're gonna go from 90, we're gonna go to 105 degrees next. Then we're going to go to 120 degrees, then 135, and then 150, then 165, and then 180. So go ahead and do that. Okay, so you should now have your whole picture drawn, and all of your points have been plotted. So like you should have been able to fill in the rest of this table here. And remember, we had stopped right at this point, so you would have plotted this point next, then this one, and then this one, and then back to the origin, and then finally this point, and then you would have landed back where we started. So basically, from 0 to 180 degrees, this picture gets drawn one whole time and gets plotted. So this is an example of a rose curve, and I could have figured out how many petals it was going to have and how long each petal was going to be right here from my polar form. Okay, so I'm going to have you guys do some investigating now, and you're going to look at some problems that go along with this, and you're just going to just basically, given a bunch of different examples, plot them in your calculator, graph them in your calculator, and see how to graph it. Oh, if you haven't seen how to put your calculator into the polar mode, and you haven't seen how to do the open circle with a tail plot, that's all stuff that you want to check out. That Zoom video that I posted up yesterday, I did figure out, I was just using the camera feature on my iPad, but I was figuring out how to get that up there for you. So I'm going to give you some examples on this, and that'll be what I need you to investigate before we go live tomorrow. Alrighty, miss you guys. See you tomorrow.